We will continue our discussion on IC engine. Today we will discuss about the ignition system. In my last lecture we have discussed about the types of nozzles and what are the objective of nozzles, and we have seen that nozzle is an important as an integrated part of a compression ignition system, CI engine injection system. So, that is compression ignition engines injection system requires nozzle, because we have fuel pump that will supply fuel from fuel tank to the nozzle, and then only to have a better atomization and desired spray pattern we should have nozzle. That is what we have discussed. Now today we will discuss about ignition system. An ignition system basically again an important system which is required for the combustion of a spark ignition engine. So today we will see that what are the different parts of an ignition system. Of course, we will discuss today about battery ignition system, and if time permits, then we will discuss about the magneto ignition system. But today we will discuss about the battery ignition system, which is again an important system for the combustion of a spark ignition engine, because we have seen very beginning of this course I have discussed that in a SI engine we require an external agent which is known as spark plug. Without having spark plug, it is not possible to initiate combustion. We are supplying air fuel mixture or charge through a carburetor, special device carburetor, and carburetor is designed to supply stoichiometric or chemically correct air fuel ratio, and that charge is introduced in the cylinder during intake stroke. During the compression stroke, charge is being compressed whenever, and at the end of the compression stroke, rather when piston is reaching towards TDC, then we need to switch on the spark plug essentially to ignite, rather essentially to initiate the combustion. So today we will discuss about the spark ignition engine, SI engine, spark ignition engine, ignition system. Of course, we will discuss about battery ignition system. Battery ignition system. So now as I said that today we will try to draw the schematic. We will see what are the different parts of the ignition system and what are the function of each and every parts of the ignition system. So now the ignition system, that is very important. The ignition system is one of the auxiliary system, is an auxiliary system, very important, required for the operation of SI engine, required for the operation of SI engine. We will discuss that what are the basic requirement that an ignition system should provide. So we will discuss after drawing the schematic that what are the basic requirements that an ignition system should provide. So the ignition system is an auxiliary system required for the operation of SI engine, that is what I told, because in a spark ignition engine we have to have spark. So to obtain the spark we require a voltage, and maybe from a battery we may not get that much voltage. So using that battery voltage, we have to have a circuit through which we can have relatively higher voltage, so that voltage will be able to create a generate a flame, rather and which will propagate very fast and consume all the fuel, and that the combustion will initiate. So today we will discuss, even if you try to recall that in a spark ignition system, if in an engine, so we have our spark plug. So this is top dead center and this is bottom dead center, and then we have a piston which is which moves between these two centers and which moves between these two centers, and this is spark plug. So, this entire circuit is spark plug. So, this is spark plug. The spark plug is an essential element for the combustion of a SI engine. Now, question is, what do we do using this spark plug? Now, if I try to draw zoomed in view of the spark plug, then perhaps we will get a schematic like this, and this small gap, we have a small gap this small gap, this is high voltage terminal, and this is ground, and this is small gap, and gap distance is nearly about 1 or 1.5 millimeter. So, the voltage, this is very important, voltage between the gap until reaches 10 kilovolt to 20 kilovolt, nothing will happen, right. That means, this 10 kilovolt to 20 kilovolt voltage is required, this voltage is required to break the resistance of spark gap and to produce spark, required to break the resistance of spark gap and to produce spark, So, this is very important. Minimum 10 kilovolt to 20 kilovolt is required to break the resistance of the spark gap, which is of the order of 1 to 1.5 millimeter, and essentially to produce spark. So, even if we have a battery, so battery at max will have 12 volt to 24 volt battery. Using that battery, it is not possible to create a spark by breaking the resistance of the spark gap. So, we should have a circuit, and if we use on battery, so battery operated circuit, which is known as battery ignition system. So, we will have a circuit, a system, the system will have different parts, different components. We will discuss today that what are the functions, what are the function of the different parts of the different components of the ignition system, and by how we can have 10 kilovolt to 20 kilovolt using a battery which is having maybe using a battery of 12 volt to 24 volt. So, now I will draw the schematic, very important, that we generate a high potential. So, we have a spark plug, the gap of the high in the spark plug, that is very small gap, 1.5 to 1 to 1.5 millimeter. We require relatively high voltage, high potential to break the resistance of the spark gap, so that we can have a spark. To do that, using a battery of 12 volt to 25 volt, how we can obtain this huge amount of the high voltage, and that is what I will discuss now using a schematic. So, if I try to draw the schematic of a spark ignition, rather battery ignition system. So, schematic of a battery ignition system. So, this is battery ignition system. So, if I try to draw the schematic, so we will have a battery, so then we have an ammeter connected, then we will have a ignition switch, then we have one resistor, then we have one transformer which is having primary and secondary circuit. This is again connected to one capacitor, then and we will have so, and then from here so all these are going to deal. So, this is I now I will have a nomenclature. So, this is known as capacitor. So, this is capacitor, this is breaker points, this is breaker cam. So, this is known as breaker cam, these are the breaker points, right. This is ignition coil or transformer, this is ignition coil or sometimes it is known as transformer. This is distributor rotor. So, this is distributor, this is known as distributor rotor, this is known as distributor, and this is ballast resistor. This is ignition switch, this is battery of 12 volt to 24 volt, right, and this is ammeter which is used connected to read the current which is going, and all these points are 2 cylinder spark plug, 2 cylinder spark plug. So, this is the entire circuit, rather battery ignition system, entire circuit of a battery ignition system. So, we have now I will discuss what are the function of different parts of the system. So, what we can see from the circuit, that in the circuit we are having one battery of 12 volt to 24 volt, but at the end we require at least 10 kilovolt to 20 kilovolt to break the resistance of the spark gap to have a spark. By how we can generate this spark gap, and for that we are having this circuit. We will discuss by how we can develop this high voltage. So, before I go to discuss about the how we can have, now I will discuss that what are the, as I said that the basic requirement that an ignition system should provide, we need to know. So, what are the basic requirement? Basic requirement then ignition system provide. What are the basic requirement? So, an ignition system must provide the following basic requirements. So, what are those? So, if I now write that an ignition system must provide the following basic requirements. What are the basic requirements? A source of electrical energy, basically ignition system must provide the following basic requirements: a source of electrical energy, number 2, a means for boosting the low voltage from source to the very high potential required to put. That is what I am telling, because you are having one battery that is 12 volt to 24 volt, but from that low voltage we need to boost up the voltage, so that the high potential that is required to break the resistance of the spark gap. So, a means for boosting the low voltage from the source. We are having low voltage in a source, from the source to the very high potential, required to produce a high tension, a high tension arc across the spark plug gap, right, that ignites the combustion mixture, the combustible mixture, So, a source of electrical energy, an ignition system must provide the following basic requirement. We will have a source of electrical energy. So, we have battery, then we have very low voltage from the source, that is battery 12 volt to 24 volt. So, there will be a system, the system will have sufficient arrangement, so that we can boost up the low voltage from the source to the high potential that is required to create a high tension arc across the spark plug gap that ignites the combustion mixture. Number 3, a scheme for timing and distributing the high voltage. Not only that, maybe we have generated high voltage, so there will be a scheme so that we can distribute that high voltage distribute the high potential to each spark plug at the exact instant so that I mean if you have a multi-cylinder engine, if you have a we will have a few number of spark plug, so that we have to distribute the high potential at to every cylinder, to every spark plug of every cylinder at a right time. So, a scheme for timing and distributing of high voltage, a scheme for timing and distributing of high voltage, that is to distribute the high potential to each spark plug at the exact instant which is required in every cycle for each cylinder, which is required for every cycle for each cylinder, which is required in every cycle for each cylinder. So, these are the requirements we need in an ignition system. So, we have discussed it clearly. So, what we have seen, the components of a if we go back to my previous slide, where we have schematically depicted the battery ignition system. Of course, we have a source of electrical energy, that is battery, and then we have sufficient arrangement to boost up that low voltage to a high voltage, which is required approximately 10 kilovolt to 20 kilovolt to break up the spark gap, resistance of the spark gap through proper arrangement. And then also we have a sufficient arrangement of timing and distributing the high potential through different spark plug, which is required in every cycle for each cylinder. I mean that will supply high potential at exact time to the different spark plug of different engines. I mean that is very important. So, now question is the component what we have drawn. So, the components of the normal ignition system consist of a battery. The components of normal ignition system, that is battery ignition system, consist of a battery, that is source of electrical energy, battery, ignition coil, breaker coils, condenser, distributor and spark plug, condenser, distributor and spark plug. The distributor unit is driven by the camshaft in a 4-stroke engine and at the half of the engine speed. So, we will discuss now that the spark plug, the distributor unit, very important. The distributor unit is driven. The distributor unit is driven by the camshaft. Of the in a 4-stroke engine, and at the half of the half the engine speed. It is very important. So, what are the components of a normal ignition or battery ignition system? We have a battery, of course, we should have a source of electrical energy, then we have a ignition coil, that is also which is also known as transformer, breaker coils, condenser, distributor and the spark plug. Of course, spark plug, without spark plug how we can have spark. The distributor unit is driven by the camshaft in a 4-stroke engine and at the half speed of the engine, very fine, very nice. So, now we need to know what are the functions of the different parts of the ignition system. So, we have that ignition switch. So, we have ignition switch, battery, we know battery, we start with battery. So, this is source of electrical energy, source of electrical energy. So, we have battery, then we have very importantly ammeter. So, we have ammeter, so which is used to meter the current, which is used to meter the current flowing into the circuit. Next we have one ignition switch. If we ignition switch, so what is the function of ignition switch? Which connect or disconnect the ignition system from battery, so engine can be stopped, started or stopped, fine. So, we know that we nowadays we start and off the engine. So, ignition switch which connect or disconnect, the ignition system from battery. So, engine can be stopped or started, whenever it is required. So, which connect or disconnect the ignition system from battery. So, by switching it on or off we can start or off the engine. So, this is the objective. We have one ballast resistor. What is the function of ballast resistor? This is also very important, because we will see that they know that ballast resistors is also important parts of the ignition circuit, but we will know. So, before go to discuss about the function of ballast resistor, what is the ignition coil? Ignition coil, that is transformer, this is the main part, purpose to step up the voltage from, purpose is to step up the voltage from 12 volt to 20 kilovolt. 12 volt to 20 kilovolt. We will discuss by how it can step up. So, this is another important. Then we have capacitor. Purpose is to reducing the arcing in the breaker points. Purpose we will now today I am writing the functions. So, when I will discuss the operational principle of an ignition system, then we will come to know what is the function of a capacitor, and if we do not have capacitor, then what will be the problem. So, purpose is to reduce the arcing in the breaker points, thereby increasing their life. We need to reduce the arcing between the breaker points, because when we connect and disconnect the breaker point, there will be a arc. So, to reduce the arc, we need to have capacitor. Not only that, we will come to know that capacitor also stored some amount of some voltage. While I will discuss the operational principle, then I will come to know. Then we have a breaker points. The breaker points are very important. By switching, by closing and opening the breaker points, we can connect or disconnect the circuit, and then we can have, we will discuss, by closing and opening the breaker points, we can connect or disconnect the circuit, I mean, so that the current will flow, and then while current is flowing through the primary circuit, there will be a magnetic field. That magnetic field will try to collapse, and that will again create an induced field in the secondary circuit, that we will discuss. Now, so the breaker points and breaker points are operated by breaker cam. They again they will be connected with the shaft of the engine, I mean maybe to operate or to close or to open the breaker points. Now, if we go back to my schematic previous slide, we have two distributing. In this figure there are two rotary element, one is distributor rotor, another is a breaker cam. So, in this figure there are two rotary elements. There are two rotary elements. One is distributor rotor and another is the breaker cam. Another is the breaker cam. So, one is distributor rotor, another is a breaker cam, right. The name of the distributor rotor comes from the fact that it will distribute high voltage. So, I will write now. So, distributor rotor, very important. So, the name of the distributor rotor comes from the fact that it will distribute high voltage through different cylinder. So, fact that it will distribute high voltage, through different cylinder, through different cylinders. So, it is important. So, what are the functions of distributor rotor? What are the functions? Right. One, opens and closes the primary ignition circuit, opens and closes the primary ignition circuit, is very important, primary ignition circuit. Distribute current in the respective cylinder in the engine, distribute potential in the respective cylinder in the engine, in the respective cylinder of the engine. That is what we have discussed. We could distribute high voltage through different cylinder, and has a mechanism, has a distributor element has a mechanism which controls the point at which breaker points opens, thereby advancing or retarding the spark as required for the system. Very important. So, this distributor rotor has a mechanism, which controls the point at which breaker points open and thereby advancing or retarding the spark as required for the engine. Very important. So, these are the different. So, we have discussed about the battery ignition system, which is again important to create a, because we have a spark plug which is an integral part of the spark ignition engine. So, we have seen that the spark gap is very small, but we need at least 10 kilovolt to 20 kilovolt to break the spark resistance, essentially to create a spark which will be required to ignite the combustible mixture. By how we can? Because we have an electrical source of energy, that is battery, of 10 kilovolt, of 12 volt to 24 volt. From that low voltage we can step up the voltage up to 10 kilovolt through certain arrangement, and we can not only can develop that high voltage, we also can we also have arrangement so that we can distribute that high voltage to different spark plug of different cylinders of engine. And this entire operation is done by a system which is known as ignition system. We have identified what are the different parts of the ignition system, and we have seen what are the functions of the different parts of the ignition system. So, this distributor rotor, as I said that in this figure we have two rotary elements, one is distributor rotor, another is the breaker cam, and breaker cam is very important. By closing and opening the breaker points, we can we can ignite, I mean the ignition coil, that we can have a flow of current through the primary circuit, or we can stop the flow of current through the primary circuit. And whenever we are having high voltage in the secondary circuit, that we will discuss in the next lecture, and that high voltage through that secondary circuit will go to the different cylinders through the distributor rotor. And we have discussed that what are the basic requirements that our ignition system provide. Not only that, we have also identified the components, and we have discussed about the function of different components. And now we will try to discuss, next we have to discuss about the operational principle, by how we can have that high amount, the high potential using a low voltage, that low potential of a from the source, and that part we will discuss in my next lecture. And we will discuss that what are the what are the problems associated with this system. And not only that, if we have a battery operated battery ignition system, and then that battery ignition system of course create a spark which we use to ignite the combustible mixture, but what are the problems and how we can handle the problem, and if we need to have any other special requirements or other special arrangement to be incorporated to the system, that part we will discuss in my next lecture. With this I stop here today, and I will continue our discussion in the next lecture. Thank you.